So that's a Danelectro pedal with a noisemaker put in instead of the original guts of the pedal. So basically what I did is I ripped the guts of the pedal out and replaced it with a circuit, which is a synthesizer, an analog synthesizer essentially, that just, depending on the knob settings, you get different tones and different like that clicking. Yeah, that clicking sound. I also had to create a circuit for this switch. So basically, it's two circuits inside. One is the synth circuit, one is the switch circuit. So this video is just going to talk a little bit about how I did that. I'm actually not going to do a step-by-step because it would just be way too much. And if you know what you're doing, it's actually pretty easy. But I had no idea what I was doing when I first did this. So this is just going to be a little bit of an explanatory video of what went into doing that. So this is basically just a self-contained synthesizer now, where the knobs just control different pots to give you slightly different sounds. So here's what the inside of this thing looks like. You can see it's hand soldered and stuff. I'll talk a little bit more about where all these things came from, but basically there was originally like two printed circuit boards, one right there and one right there, which I took all the pieces apart. Now I really wanted to like use all the pieces to make the actual pedal, right? So it was like kind of a complete remake of the original design. That didn't really work. I mean, I might have been able to do it if I had slightly better knowledge about because there was an oscillator circuit in this thing. If I knew a little bit more about that, I might have been able to do it. But what I ended up doing is finding online instructions where I had to build an analog synthesizer. Those original design is right here. This is from a little electronics notebook put up by, I think, Forrest Mims is his name. I think you could get them at Radio Shack in the 80s. But yeah, so essentially, like that's the double circuit. There's two 555s in there, and that's what gives you the basically the oscillation frequencies. There's originally supposed to be two pots, so I added two more. I think, so one on R3, I think, and then the C2 was that's a switch. So I put a switch on that one to go with different capacitors. The switch doesn't quite work as well as I thought it would have, but in any case, that's what happened there. I'll link to this original design, but this is how I started. So I started with trying to just build this thing to get it to a working thing. Now I had the switch. The light doesn't work, which is weird because it did work when I wired it up. It doesn't work now. But the switch was non-trivial because, I only could put the switch in one place, and I wanted it to be an on-off switch just like a pedal, not one that you could hold down. So I did have to design that. I got that from another place. Hold on. Yeah, here's the design for the switch. I actually don't quite know where this came from. This is another 555, which was cool because I had just bought like a bunch of them and then just could use them for all this stuff. I'll try to link to what some of the videos where this came from, but it's sort of like my own design combining what I could learn about the 555s and what some other people were doing with the switch. So the second link will show you where that came from. So after I had both of these things done, and I'll try to show you the video of all of them working together as a prototype unit. So after that happened, I had to figure out how to get them into the pedal. So actually this is the final. I'll also link a nice or like a PDF of this, but this is the final circuit design where everything's in there. So that's the switch that goes to the different capacitors. There's the two original 555s to create the oscillation circuit, and there's the switch circuit. And then the battery is right there. Is right there, right? Okay, so that's the whole circuit. And then I had to put it inside the pedal, so I had to redesign that a few times. This was my first attempt because that's what the thing looked like. I just traced it and then put stuff in the right place where I thought it should go. So this isn't a literal design. This isn't like exactly where all the circuits go, but I had to kind of redo it a few times because I don't really know what I'm doing, right? So I put it in one place, it didn't fit, put it in another place, and then, the trick was, like, there's a whole separate circuit up here, so I had to, like, connect the circuit in complicated ways. So figuring out where things went and what should have been close to what other things was tricky because, in a circuit design, you just draw a line, but that's like a real wire, and it might be inconvenient to put it in one place or the other. Anyway, the top I had only as the jack the first time, but then I thought that that this was getting too busy. The switch was down where the 555 was. So then what I said was, okay, let's put the switch circuit up here. So then I have wires running from the original switch up to where the switch circuit is. And then that's also where I put the jack. So this was actually the original, the real design. So I'll take a PDF of this and put and link to this underneath the video as well. So here's the entirety of the circuit prototyped, right? So not put into the actual PCB boards that I'm eventually going to use. So just, it's basically in like 3 to 4 parts. This is the main sound system, the frequency creator. You can see that I've got the 2 555s here and 3 potentiometers, which are going to replace variable resistors in the original design. Actually, these 2 variable resistors are variable resistors in the original design, and I just added another one for another resistor. So that's the sort of sound module. I have an 8 ohm speaker here for testing, but then I also put a jack on it so I can plug it into my amp first before checking, before the final assembly, just to make sure that it actually could be put out to an amp and that I understood how the jack works. So there's a jack there. So that's the entire sound circuit. And then over here is the switch circuit. So I had to Google that separately and figure it out myself, but this is just the switch circuit. And here's the power source, which goes to the switch circuit. And of course the switch circuit's connected to the main synth circuit. And then here's the switch, which is connected here as well. So this is kind of a unit. This is kind of a unit. The unit over here is actually part of the original sound circuit. It's one capacitor in the original circuit that I've switched, that I've replaced with a switch and 4 individual capacitors. This was a 4-pole switch. It actually was a 2 terminal 4-pole, and that was really confusing to me at first. But I just soldered 4 of the things together, and now it's just a 4-way. It just acts like a one terminal, and the other terminal has 4. So it's like a 1-pole 4-terminal switch now, because I'm going to solder 4 of the terminals together. Okay, so that's outside of the actual PCB boards. This is how I did prototyping it to make sure the whole thing actually worked, which it totally does. There's a diode here that turns on and off when the switch goes on and off. Yeah. All right, so I've done this in a modular manner so that I broke up the plan into 3 different parts connected by these wires. So I've soldered on super long wires for the connections between these 3 boards, and I use that for testing. So I did this one first. Which was just one, what I could put on one prototype board, and then I soldered it up and then connected the wires to the other thing, which was the other thing that was on the prototype board, which happened to be the 2 oscillators. And so I hooked that up and connected this to the prototype board to make sure it works cool. Then I did the same thing to this, which is I pulled off the other prototype board, soldered everything onto here. You can see that I went, I went under for the most part to keep the insulated wires on one side, but like in other cases I had to go underneath. That's just board design. I'm sure if I knew what I was doing, there'd be like some method to the madness, but I was just trying to figure out some way that actually worked because I don't really know what I'm doing. And then I put the oscillators on the double oscillators on a single board. This is the 3 capacitors for the knob circuit, and then everything else is here. Okay, so now you can see the thing all wired up. You can see that I basically copied the base of the original Danelectro, and then sort of got 3 pieces of PCB, or not PCB, but the perf board, I guess. Got 3 of them, made them about the right size, epoxied them together. Well, I epoxied 2 of them together this way, and then the top one is actually attached just with wires. It's actually not fixed in any way besides just with wires, so it's kind of loose. And then the top one I mimicked the, sorry, I don't have it on hand right here. The top part of the Danelectro, which held some kind of timer circuit and also the 2 plugs. So my top circuit still holds the plug. I had to do that, of course, because I wanted it to fit in the same place where the Danelectro plug is. But then I just put whatever I could up there, and it just so happened that the circuit that controls the switch just here, and also I couldn't put the switch anywhere else because obviously I wanted to use the same Danelectro pedal switch, so I couldn't put that anywhere else. So I put that there, and the plug there. It's the out, because it's an out, and the in just doesn't do anything anymore. And then I put the pots up here. They were super tricky to match the exact same place. Of course, you like these to match the perf board. So if you just put them in the same places, you can see where the pots were. They were right. Sorry, it's on this one. They could see we're right there, there, and there. But of course, this one wasn't quite exactly in the right place for the piece for the perf board. The rest of them all lined up perfectly, so it was a real kind of a nightmare to do that. Also, I had to mod out this switch, this rotary switch, incredibly. Like, I could not buy a rotary switch that worked for this. I have a big circular one like this big. I even modded this one. I had to like take out a little ring here to make sure it fit big enough, but actually it was just too circular, just too big. It just couldn't fit on the PCB board, which I found out after I put the rest of it together. So that was kind of a nightmare. So I got these little 6-ways. Sorry, they're 4-ways. They have 6 pins, but they're 4-way switches. So 1 terminal, 4 outs or whatever. And then I glued one of the old pot staffs or whatever, knobs, using epoxy. And so I drilled a hole in there, stuck it down into there. It was pretty nasty. I don't know how long it's going to last, but maybe it'll last long enough so that it will get a little bit of playing time out of it. New diode, because I couldn't make the original diode work. So it's a new diode, but the new diode does work. Yeah, so this is what it looks like. And of course, I had to measure all these things. These things were all cut. So I installed it into the Danelectro, did all the measurements, or approximately all the measurements, and then sort of wired them up. So that it comes out looking like this when you pop it out of the Danelectro. And so now, in principle, I'm going to put it in and like never think about it again because it's going to totally work forever.